Okay, hello students. Here I will continue with the continuation of 4.6 practice problems. So last time I think I finished with 5 and 6. So this time I would like to 5, 6, 7, and this time I'm doing problem number 8. Now this problem is about Newton's law of cooling. So a hot bowl of soup is served at a dinner party. It starts to cool according to the Newton's law of cooling. So you're already given the temperature of the hot bowl. So that means what is the temperature in the beginning? So it was very there is always a room temperature in the beginning, and so let's understand each of those things. So the first number that you see 65, 65 is where the temperature of the room present room temp. So that's 65. So this is 65 here. Then in the beginning, the bowl, so let's see if this is the bowl with the soup here. Now this soup is, this 146 is the difference between, now what is this 146 actually is? 146 is the difference in the original, so that means temperature original minus the room temperature, which is 65 here. So all you do is you add 65 both sides and you get 211. So 200 little less than 1 degree Fahrenheit less, because 212 is where the water boils, right? So 212, so that means 65. So somewhere here the room is, so this is somewhere here is 211. So the temperature right here is of the bowl is 212, and then it goes on decreasing. And they also give at what percent it is going down. You can clearly see that it's given to you e raised to r. That r is 0.05, which is 5%. So from here to here, let's see, one minute. Let's see if it is 1 minute, then it decreases by 5%, and then again the next 1 minute it decreases by whatever the temperature here. That temperature 5% will be reduced. That means 95% of the temperature stays. So now what we do here is, so what is the first answer is, the first question is, what is the initial temperature of the soup? So all you do is you add this number and this number, which is 211 degree Fahrenheit, and you're done. What is the temperature after 10 minutes? Now, this question, all you do is you have to use the calculator. So the function is given, so T of 10. So you put T of 10 and 65 plus 146 times e raised to minus 0.05 and multiply by, you just plug in the temperature after 10 minutes. So you put multiply by 10. So let's go directly and plug this in the calculator. So I'm sure you can see what I'm doing right now. So go to the calculator. So I'll start with the new one. Instead of a start with calculator, and I want to know starts with 65. So put 65 plus 146, and then e raised to, so here the e raised to, and then you're going to put minus 0.05 times, and you put 10, and you get the answer. And you get 153 point. Now they ask you to round this to the nearest 1553.55. So this we can reduce this 5 can be reduced to, since it is asking 1 place decimal, so it will be 153.6. So I'm going to go back there and write this is 153.6 Fahrenheit, and that's it. And the last question is, how long will the temperature will be? 200. So how do we do this part? So for this, I need the equation, right? So the equation, this is the original equation. I'm gonna make a room for me and write, okay. So this is the main equation. So we need to know when will this temperature, after how many minutes the temperature will be 100 degree Fahrenheit. That means suppose this is going down and down like this. If you see this part, this temperature is going down, 100 maybe somewhere here. So we want to know when will this temperature be. So this part, when is this? So our question is, we go down here, we need to know what is this T. So after how many minutes will the temperature be degree Fahrenheit? So all you do is uh, solve this. So we'll plug in the left side by 100. So this is 100 equals 65 plus 146 e raised to 0.05 t. Remember the formula, that shortcut formula that I gave was this. If you have something like this e raised to rt, then t becomes equal directly ln of a divided by a naught and divided by r. Or r could be written as ln of same thing, but this time we divide by t. So we can use this, but then this is equal to directly the exponential part here. On the extra part here, you see only 65. So basically, you're subtracting 65 both sides. So this will be 65. So that way we can cross out this 65 and write down this 100 minus 65 is 35. That is 35 equals, this will be 146 e raised to minus 0.05 t. And you can directly apply this formula. It means this part is like your a, this part is like a naught, okay, and this part, this is the t. That's the question. This is the r. This is the whole thing is r. So you can directly do, but still I would like to show, sometimes you really want to know how did you get that. So let me write one more time. This time you're going to divide 146. So eventually you are subtract 146. So this 46 goes away, and then you get, I'm gonna swap this. So I'm gonna write e on the left side, e raised to minus 0.05 t equals, keep 35 the quotient as it is, and then change this to logarithmic form. So how do we change from exponential to the logarithmic form? Is the input for the input right here is this is the input, okay, and this is the output. So when you want to write this in the logarithmic form, so we'll write logarithm, but instead of logarithm, I will just write ln because the base is e. Remember this basically you're supposed, this actually it is logarithm to the base e. This is how it is, and this becomes the input. So ln, and then the output. So this is the output. This output now changes to input and equals, and the input right here becomes the output minus 0.05 and t. Okay, and then you divide by minus 0.05 and minus 0.05. So let me also write this. So we can cross out this, and you get t equals minus ln of 35. Okay, I want to make sure we are writing this correct, 0.05. And this is what you plug in the calculator, and we should get the answer. So if I go ahead and put minus here, so minus, or we can use this minus here, and then log, so ln, so here you can see that ln is right here, so control this, and you put the quotient, so put the quotient, you click this one, and it is 35, now down is 146, and this whole thing is divided, so I use this divide by um, 0.0.05 and enter, and you get the answer as 28.5. But they ask us to round it to the nearest whole number. So that means if we don't want anything, any digit after the decimal. So after the decimal, there is a tenth place, there is a 5 there. So we can round this 8 to 29. So your final answer will be, so this will be 29 29 minutes, sorry. So that's like how many minutes, after how many minutes the question was asked. So here it is in the Cengage, you just put 29 and you're done. So hope this is solved, even though it took me 10 minutes, but I just wanted to make sure we all understand. The main thing is this part where when in the beginning, how much is what was the temperature of the bowl? So we want to know that. So you have to add these two things. So make sure we get that part correct. Another practice problem, yet again, let's take this as problem number 9. So the number y of hits in a new website receives each month can be modeled by. So you are given a exponential function where t represents the number of months the website has been operating. Only thing it gives an information that the website's third month there were 10,000 hits. So what does y represent? Y is number of hits, okay, and t is the number of months. Okay, so the question is, in this function that is y, so y is 4060 e raised to kt. All you do is you need to figure out what is the value of k. So you are given input output, that is when the input is like a third month when the input is 3, the output is 10,000. That means this is t is the 3 and the y is 10,000. So all you do, you put a 10,000 right here equal 4060. The first step is better to write down this because we need to find the value of k. So the first question, what is that k? So e raised to k times and the 3. So you can use the shortcut formula, the one that I gave you directly, that a equals uh, a naught e raised to rt. So you want to figure out the r. R is directly ln of the a divided by a naught. So it's always the logarithm, natural log of this one a divided by this one, and then whole thing divided by whatever is here, that is the r. So we can write here. So this a which is right here is this a. This is the a. Then this one is the a naught. Okay, and t is I'll take black color. So let me use this. This is the t. So t is 3 here. See, this is 3. So all you can do is directly you can write. You want to figure out what is k. So k is ln of the red a. So that is the 10,000, and then divided by a naught. That is 4060, and this whole thing divided by the black 3. This is, and you put in the calculator. Let's put this in the calculator and see, what do we get there. Okay, so let me go back to the calculator and I'll start the new one. Yeah, okay, and then we need to put ln. So that's the ln. So go right here, ln. Or because you're going to divide, let me take a division here, quotient. So I'll put here the top one. We can use ln of 10,000, and then divide by what is that number? Yeah, 4060, and then divide here by 3 and click on Control Enter, and you get point. Now they asked us to round the k to the nearest 4-place decimal. Now this is point. So you have to be very careful. This is the second place, the third place, and the fourth place. Now after the fourth, there is a 6. So that 6, because of that 6, that 4 can be increased by 1. So you get 0.3005. So I go back there, 0.3005. So your answer is, so let's go directly and write the k So this k will be, because they asked us the first question is what is this k, right? So we write uh, 0.0.305. And the second question is, now that we have already this k, I'll replace this by, so this is the main equation. And now I'm going to replace this by 0.0, sorry, 3005 and t. The second part is use this value to predict the number of hits the website will receive after 23 months. All you do is, if the input t is 23, what is the output is the question. So plug it in. So all you do is plug it in the 23 right there. So this will be y is 4060 e raised to 0.3005 times 23. Put this in the calculator and you will get the answer. Check this out. They're asking also round it to the nearest whole number and you will get the answer as 40. It's like 4,075,232. Can check this yourself. Okay, so that way I can save my time and go to another practice problem number 10. So practice problem number 10 is asking us to, yet again, why we learn log and exponential function. Here, the management at a plastic factory has found that the maximum number of units a worker can produce in a day is 40. So that's the maximum. So in a day, nobody can, nobody can, nobody can produce more than 40. So 40 is just like a horizontal asymptote right there. It's like you have like this way, and there is that horizontal asymptote. Let's say so. The maximum they can produce in a day is 40. That means in the beginning he may not produce nothing like first, and then it may go something like this, and slowly it goes on increasing and increasing. Maybe maximum is increasing is 40 there. Okay, so the first question is the learning curve for the So the learning curve for the number of n units, so n is the number of units produced per day after a new employee, produced per day after a new employee has worked t days is modeled by this. So they already given this. T is how many days have been passed the employee has been working, but they have given us one input. That means if a worker has worked 20 days on the job, if he has been working for 20 days, the after 20 days, a new employee produces. So that means a new employee, after 20 days, he produces 18. That means after 20, it is 18. It means the input is T and the output is the N. So N depends on the number of products produced. So here we need to figure out what is this K. So it's the same problem like last time. All you do here is this part is N is given to use 18. So this part N is 18. So I'll put 18 equals 40 and then 1 minus e raised to k times after 18. So this becomes 18 there. Now all we need to do is solve this equation. So first step is of course different ways you can do. Let's do directly divide by 40. Okay, this 40 will go away and you get, I will keep this 18 over 40 as it is without changing. So that becomes 1 minus e raised to 18k because k times 18 and 18k is the same thing and we want to solve for k. Now then subtract 1. So let's subtract 1. When you do this, you get 18 over 40 minus 1, which is equal to e raised to minus 18k. Now here I'll try to do a little of kind of getting the same denominator because there's a 40 and this whole thing become 18 minus 40 divided by 40 equals minus e raised to 18k. And there is a, I think I should have directly divided by minus 40 because, oh, sorry, you subtract 40, but there's a minus 1 here, so I'll divide by minus 1. So this will make it, so dividing by minus 1, of course, you can do different ways also. And I'll try to swap this. Instead of 18 minus 40, I'll write it as 40 minus 18 because of this minus sign upon 40, and this will be equal to e raised to 18k, and then you can use directly. Also, you could, the k, remember the k is ln. Now you want to change from exponential to the logarithmic function. So ln of 40 minus 18 divided by 40, and then equals to, so this input which is right here becomes the output 18k, and then you can divide by 18, and so this 18 goes away, and this is what you put in the calculator. So let's put this in the I think I made a slight mistake in it's after 20 days. So remember, the question was after 20 days on the job, the new employee produced 18. So this should have been this part. This is 20. So I think you guys must have realized that. So I'll make these changes here. So this is 20k. So this has to be 2020. And then when you do here, this has to be 20 here. So because this is 20 and you're dividing by 20, I hope I make some sorry about that. So this becomes k equals divided by 20. And this is what we'll put in the calculator. So minor mistake, but I'm sure you understood it. So let me go directly to this. And you can see, you can use the old one also. I have here already, just enter and just make those changes there. And I will write it was 40 minus 18. And then go down and divide it by 40. And this divided by 20. And then enter, control, enter, and you get minus. And now you have to round this nearest to the 3-place decimal. So if you see, this is first place 1, 2, and 3, and there is an 8 on the right side. So that 8, this 8 will make this 9 to add 1, so become 10. So that way this will become 0, and this 2 will become 3. So you get the answer as point minus 0.030. So I'm going to go back and write down here. So this becomes 0.3. So that's the first part. And the second part of this question is also to find what is n. Find the learning curve for this employee. First find k. So they're asking you first find k. So plug in this k, that is, this is minus 0.030, because you want they also need to write the equation now. This will change now. How this will change? So that becomes equal to 41 minus e raised to minus 0.030t, and you're done. That's all you're supposed to put. Now the next question is asking, after 26 days, how many how many days should pass before this employee is producing 26 units? That means they gave you n, so it is 26 equals 40, and then it is 1 minus e raised to minus 0.030t. So this time it's the same thing, except that last time, remember, they gave this was 18 and we had to figure out this was k, and then so everything exactly the same. The first thing is divide by 40 like this. So this goes away, and then you're left with 26. Let me show all the steps so that you never get confused. 0.030t, and then you subtract 1 both sides. So when you subtract 1, so this will be 26 over 40 minus 1, this goes away, and then minus e raised. All the steps, same thing. And then you can make the you can keep this as it is also. What I'll do is just divide by minus 1. That's another way to do shortcut. So that way instead of writing this, I can this minus 1 will see it, if I have a minus b over minus 1, it is same as b minus a. That's all it means. So you can write this as 1 minus 26 over 40 as 1, and then this equals e raised to minus 0.030t. And directly you can say, okay, now change from exponential to logarithm. So ln of 1 minus 26 divided by 40, and this whole thing divided by minus 0.030, and that will be t. Now, if you get confused with what I wrote here, what this basically means, let's put it like this. If I have 5 equals e raised to minus 4t, what all this means is you write logarithm of this output become the input, and equals, and the input which is right here is the minus 4 over t. There you go. And then finally you have to divide by minus 4. So that's how it is. So this go. So t equals this t, whatever the variable this t is, ln of whatever is on the left side, and then divide by the coefficient here of t. So that's all I did. Directly you can use this trick, or you can remember it is like if I have e raised to k of a equals b, and you want to find what is this a, then a equals ln of b and divide by k. So a lot of shortcuts are there, but if you get confused, I would just go according to this. Now using the calculator, you need to put this in the calculator. So first put ln, and then put the 1 minus, and then put quotient, something like this. Okay, and then put that part, and then everything. When you have ln of all this, then you divide just using the forward slash. That would be enough. Or you could even also begin with. Okay, let's do it. Let me show that ln. Let me write on my paper so that I have that thing. Okay, let me go to the calculator. What I'm saying is, yeah. So first I want division, right? So I have this one. Now on top you have ln, and there is 1, and there is plus, and then you get again the quotient, and there it is 2 6, and here you divide by 40, and down is minus 0.30, sorry, 0.030, and then enter. So control, and you get, I want to go back there and make some changes, so you can always go for back the upper key, and then enter. And I need to edit this because this is 1 minus. And now you say control enter, and you get 34. So you have to round it to nearest whole number. So this we can see there's a 9. So that will be, this will be 35. So it will take 35 days for the new employee to do 26 units per day. So that's how the problem gets over. So this is, with this I would like to, so this was a nice problem. Hopefully I've completed 5, 6, 6, 7, 8, 9, 10. In this video I'm doing 3. And I don't know, I want to, some of the students were missing for problem number 1, 2, 3. Let me see the first problem. So the question number 1 was asking us, question number 1 is a 15-gram sample of radioactive iodine decays in such a way that the mass remaining after T days is given. So you already given this. Remember, this is exactly like A equals A naught is what was in the beginning and given by E raised to RT. That means in the beginning it was 15, and then the radioactive substance goes on decreasing, decays. Okay, and that's what they gave us. Start at 15, and the question is, after how many days will there will be 5 grams? So if this is 10 and 5, so we need to know when will this be, after how many. So this is where we want to know what is this t number of days for the 15-gram sample of radioactive iodine will be 5. When will it be 5 grams? So all you do is you can use direct. So the thing that I showed this in the class. You want to figure out the t. See this t is the t becomes equal a. It's it directly you can write down ln of a. A is the so the a because they give us there is somewhere it says 5 grams. That's when it's going to be 5 gram divided by what was in the beginning and divide by minus r. That's all you're supposed to do. Or if you get confused to what I'm saying here, okay, let's put the now 5 milligram is remaining. When will this empty? Empty stands for the is measured in grams. So we want to know how much. When will that be? 5. So all you do is you put a 5 here and work this problem. Solve for t. So let me write a big one. So I'm replacing. So if this is T and this is MT milligram after so many days, so this is the input, the days, and this is the output. So this is like it's like X and Y, and this is the days, and this is amount of milligram or gram, amount of grams remaining after decaying. So all you do is put this empty is 5. So this is 5 equals 15 times e raised to minus 0. This is already given to 0.091 t. See? So it means it looks like that r that you see here is r is 0.091. That means r is 9.1%. So it is decreasing by 9.1% of what was earlier. So first step is divide this by 15. So we divide by 15. I'm gonna keep this as it is. Not always is going to get cancelled. So that way, so this 15 goes away. So I'll take this off to save my room there. And now I want to switch this to ln form. So the input here is this, and this is the output. And remember the shortcut trick. And so the input, when you want to write in the ln form, logarithm form, logarithm with the base e, and the output is 5 over 15, and the input is this everything that is minus 0.091 and t. And then you divide by, because you want to solve for t, right? So it's minus 0.091 and this is minus 0.091. So remember, when you write log, when I write log with the base e of whatever that is, then it is same as ln of this. So instead of log, I'm going to take this off because in the calculator you're going to use ln. That's it. So this crosses out and you get this goes away and only t will remain here, right? So this will be t, and this is what you get in the calculator. You plug this, and I already showed those 3 problems all this while. But so you should get here the answer you're asking rounded to the nearest whole number. So if you get 11.8, something like that, you can round it to 12. So the answer here is 12. And I hope I'm making sense here. Practice problem 2 is a small lake is stocked with a certain species of fish. The fish population is moderate. So already you're given a fish population. Uh, and what does this 18 now? Where P stands for the number of fish in thousands. So this is in thousands, so very important information. So even though they give you 18 here, so if I say 18 means basically means it is 18,000 fish. So that's the maximum the fish can go. That means if you have in the beginning whatever the fish is 0, it can grow. So something like this. So if you see the graph, if you put this in the calculator, it will go something like this, go and then slows down something like this. So that's the graph of this will be. So anyway, they are not asking us to show the graph, but all they're asking you is is find the fish population after 5 years. So all you do is just plug that into. So P of 5 is the 18 is given. So that's the maximum 18,000 the fish population can go. That's like there's a horizontal asymptote y equals like 18,000. That's the maximum it can go. 1 plus 4 times e raised to minus 0.8 t. So all you do is this t which is there, you substitute multiply by 5. This you multiply by 5 and then plug this in the calculator. As I said, I have been showing so many times, and by now you should be able to. If you do not get this, please come during the after school or during the CCP. I can show this to you personally. But when you do this work, you will get answer like 16 point because you want to round it to the nearest a whole number. You may get 16.771. So you have to round it to because this even though it is 16,000. So 16,000. Okay, let's really do this, and I'll have to go and start the new page. Here it is, calculator. So there's a quotient. So click here, and then I take this, and then there is a 18 up in the numerator, and divide by 1 plus 4 e raised to the power, and then minus 0.8, and then multiply by 5. And then control enter. I think I made some mistake. Yeah, see, I made a mistake in entering that E. We have to use the other E, so I'll edit this, go back here, delete this. So this E has to be, this has to be this one, and then minus 0.8 times 5. And now I enter, control enter. And you can see clearly this becomes 16.77. So this basically means it is 16,771. See, so you have to multiply by 1,000. So this becomes 16771. 0.2, but because this 2 is lower than 5, so we want to make this round to, let me write 16.771292. So let me go back here. And so this we got, let me see the exact number, like 16.771292. So basically you're multiplying by 1,000. And when you multiply 1,000, it becomes like this, 1.2, like this. See? So that means we have to round it to the whole number. But after the decimal, the number 2 is less than 5. So this stays the same. So 16,771. So this answer over here is 16,771. So I hope that takes care. Now the second question is, after how many years will the fish be 9,000? So I'll have to take this off and put 9,000 there. Means just a 9 because, and then the t I have to take this off. That's what we don't know. When will this be 9,000? So this will be t. So we don't know this t. So that's the goal. What is this to? Okay. Now, how do we do this? Now, this is the thing. This is the denominator. You can this is like use the cross product. This multiplies here, or you can also make this 9, and I'll just keep as it is. Or just multiply this here. Cross product. The whole parenthesis, the right side will get multiplied up with 9 multiply. So when you multiply 9 there, so this 9 multiplied to 1 will give just a 9, and plus that 9 multiplied to 4 will give you 36 times 08 t, and equals, the 18 stays the same because 18 and 1 is 18. Now you subtract 9, subtracting 9, you get this goes away. to get 36 e raised to minus 0.8 t equals 18 minus 9 is 9. And then you get, of course, we know that it's easy. 18 minus 9 is, if it was something else, I would just keep it as it is, then divide by 36 both sides. And then we have what left, this 36 stays, so e raised to, I mean, that crosses out. So this becomes 80 equals 9 divide 30 is 1/4. So you can always write 1/4. And then you say, okay, how do I change to ln form? So the ln of the output will become the input here equals, and the input, which is right here, becomes the output minus 0.8t, and then divide by minus 0.8 both sides. And this will cross out, and you put this on the calculator, and you will get answer as 1.73. Remember, they're asking us to, uh, after how many years will the population be 9,000? And round it to the nearest two decimals. So I placed round it to the two nearest. So practice problem number 3 is about environmental scientists measure the intensity of the light. So as the light, you can see the on top this one, the intensity of the light is 18 lumens, but as the light goes in inside, the intensity goes down. So the way they have already modeled here, I equals 18 times e raised to minus 0.007 x, where x is the number of feet it is down, x is number of feet down, and I is the lumen at that. How much is the lumen at that level, that that much deep inside? So all the question they're asking is, the first question is asked, find the intensity. What is this I intensity of the light at the depth of? So they're asking you at the depth of x equals 40 feet. So all you do is plug in this 40 right here. That's all you do on the calculator, and you get the answer. Supposed to round to the nearest two place decimal. So you will write 18 times 07 times 40. Put this in the calculator, get the answer. The second question is, and the answer for this one, it is 13.60 lumens. That's the intensity of the light at the depth of 40 feet. The second question is asked, at what depth? Like they're asking, what is x? It means what is this x here? So that the intensity is this part, which is, this is a question mark. We don't know. And if the intensity is given to us is 9 there, they say, if it was 9, then so all you do is, this is the formula. So I will take this 40 out. So that's the x there. So this is x, right? So all you do is you put I as, this I is 9. So this I is 9. So you put this as 9. 9 equals 18 times e raised to minus 0.007. And you can see there's a minus 0. That means 7 almost like 0.7%. So, so every 100 feet down, it is just like zero point 0.7 lumens decreases. So, so now all you do is solve for x. So this is short, as I said, you can use my formula. This is like, I would like to use directly this one, e raised to maybe RT. All you do is just, you want to know what is this x. Let's say you want to find t. Just put ln of a naught and divide by that r. The r in this example is minus this. So if I want to figure out this x, you put ln, and then the a, this is the a, and this is a naught. So I put 9 over 18, which is half, of course. And then the r here, instead of r, it is minus 0.5, because decreasing. And you do this and put in the calculator, and you end up getting 99 feet. Or you can write it at 9, round it to the one place decimal, so you'll have to put it goes to 99.0. So one place decimal. You can check this out on your calculator. Practice problem number, question number 4 is Suppose you are driving a car on a cold winter day and 25 degrees is what is outside the temperature and the engine overheats about 225. So if you see outside and this, if you subtract 225 minus 25 gives you 200, and that's why you see that 200 right here. So when you park, the engine begins to cool down. That means in the beginning, the temperature is 225. So the engine is so hot that it is like more than the boiling point which of water, which is this is like 225. And the outside temperature is 25. So maybe somewhere here is 25. So there is this is the outside temperature. So there's a horizontal asymptote here, right here. So which is right here. I'll put it like t equals 25 here. So the temperature of the engine, which was 220, and begins to cool down. Like in the beginning, it cools is faster, and then the way they gave us even the percent of cooling also is given. There is a there is zero point 0.8 is a minus 0.18 means the at what rate it is uh, cooling down is it is 18%. See, so 18% going down. So this is how, and then finally it will almost come closer to the outside temperature, which is 25. Question is asked is solve the equation for T. So and the second part is find the temperature after 40 minutes. So once you get that equation, we'll solve. So we want to know T equals what? That's our question here. So let's start with whatever they gave us. The ln is given. So this is the equation given. So I want to change this equation to the exponential. How do I change from ln? So if we have, listen, ln of, remember ln of, let's put like a is b. That means it is e raised to b is a. And the question is why? Because this is logarithm of a to the base e, because ln means natural number is and base is e. So this is how it is. So then you, from this, by definition, log is the inverse of the exponential. That's why I say this e, how many times you multiply this b to get a. That means its answer is b. So e raised to b is a. So this is the shortcut we can use directly here, and then the input, see this part input, and this is the output. So output becomes the input. So you write e raised to minus 0.18 t becomes equal to the output here, which is t minus 25 divided by 200. And then use multiply 200 this side and multiply 200 right here so that we can cross out the 200. And then at the same time, you can see there's minus 25. You add 25 both sides. And this crosses out and you get T equals 25 is the room, the outside temperature, plus 200 is the difference between the engine in the beginning and the outside temperature, and this e raised to minus 0.118 T, and this is all you are supposed to put in. This is what you're supposed to put in the right here. And the second part is 40, so you plug in the 40 right here. So T of 40 is 25 multiplied by 40, and then the answer will be this you are plugging in the calculator, and the answer we're going to end up is I want you to write in one place decimal, you'll get 25 point. As I say, if you get confused, please ask me. Question practice problem number 6 is this uses a population model. They give you, so there is a bacteria which is in the beginning is only 40 and then it doubles every 6 hours. That means in the beginning, this is like in the beginning it was 40, then 1, 2, and 3, and 4, and 5, and 6, it becomes 80. That's all this means. It doubles, right? From here to here, it's like a 100% growth rate. So that's why we have this will be this takes after 6 years when t 6 hours. So 6 hours. So the formula is already given to you. Otherwise, also, if it is anything doubling, the formula is always in the beginning what you have, and then 2 raised to t number, and then a is after how many days, how many hours, it becomes half. It means if this is the whatever the a naught, so half this will be a naught divided by 2. So 1, 2, 3, 4, 5, 6. So that means basically this is becomes right, something like this, and then it goes down and then like this. Sorry, doubles, right? So doubles. I made a mistake here. This is I thought I'm talking about radioactive substance. So this in the beginning it was 40. Suppose this is 40, and then become 80. So this is the point. So the graph is doubling, something like this. So this is how the question is. So So all you do is put nt equals, in the beginning there is 40, so put a 40 right here and doubling, so 2 raised to t divided by 6 hours and you're done. That's all you're supposed to put here. And what is the population after 19? So you put 19 and put 19 divided by 6. In the calculator put this and you'll get the answer as 359. Round it to the whole number. There's one more question is asked, when will it be 1 million? Now, what is 1 million is? 1 million is thousand, right? So all you do is, instead of this nt, you put 1 million here equals 40, and it is 2 raised to t over 6. So how do we solve for the t? So divide by 40, so I'll just write 40 here, and this will cross out. So you will be left with 2t raised to 6 equals 1 million divided by, and then you need to now change this to the log form. When you put a log, when I write the logarithm, it is always the output is written as the input, and the input is written as the input is t over 6, so that goes right here, and then multiply 6 both sides, because you need to solve for both. So this 6, and put this in the calculator and you will get answer as 87.7 hours. We are done. So I hope this takes care of all the problems on 4.6. And then quiz number 9 will be easy. It's almost the same kind of questions, in different situations. And I hope this video will help for those of you who were absent in like last class also. And nobody can complain you don't know. So this is the complete 4.6 I did. Problem number 6, 7, 8, 9, 10, and then I did 1, 2. I think I did 6, 7 was a separate video, and I did 8, 9, 10. Hope that takes care.